Today we're going to talk about 6 different ways to show or think about multiplication. Because what multiplication is in words, maybe you saw this on a pretest this morning. What multiplication is in words are taking groups of groups and putting them together to get a product. If I take 3 times 4, I'm taking 3 groups of 4 things. 4, 4, 4. And I put it together and I make 12. That's it. Sounds far more complicated when I ask you to explain what multiplication is. That's all I'm asking for. It can get more complicated than that depending on how many digits are in your number, right? But overall, it's just groups of groups. You may be taking big numbers of groups of big numbers of things, but it's just a process of finding out groups of groups. Diagramming. What does the word diagram mean? I can't say your name, but if you raise your hand, I can call on you. Sir.
Diagramming means like a picture. Or like
You can stop right there because you already got it right. Doesn't have to be any more complicated than that. Diagramming means showing something in a picture. So if I take that multiplication problem, a way to diagram it, I always use X's. You could use, if you want to use smiley faces, if you want to use bunnies, I mean, you could literally do anything, right? I always use X's because they're easy and they're pretty easy to keep neat and my handwriting's messy. 3 groups of 4. 1, 2, 3. For a total of 12 X's. So if you're asked to diagram, that's it. That's what it is. I'm going to do another bad YouTuber thing and move this camera closer so I'm going to slide your stuff, okay? Whoop.
Okay. I'm not lying.
All right. Pluses of using diagramming. I'm going to let you write your pluses and minuses in there. I'm going to talk to you about them. That way, you guys can pick what you want to write in there, and I'll talk about everything. A plus of using diagramming. Kids like to draw stuff. I will tell you, if you have trouble memorizing your straight up regular multiplication tables, just using the numbers, write the numbers, then draw it. Because what that might mean is your brain processes pictures better than numbers, and pictures still do the trick. Other positives of using diagramming, can you think of any? That's kind of the hardest hitting one, right? If you're trying to solve problems, you can sometimes look at a drawing and see the pieces rather than just thinking about the numbers. Sometimes seeing the pieces really helps. But that's what a diagram is. It's seeing the pieces. You can diagram in science. You can diagram in reading. You've already diagrammed in reading. Do you know what you diagram in reading? Your plot arc is a diagram of the plot. Put it on a big arc. You put your pieces in place. You can look at the story in a picture. Minuses of diagramming. Okay. Your hand just goes, bing! So I think you're thinking the same thing as me.
It takes way too long.
It takes a long time. Picture with me. 3,497 times 943. Now diagram it. Nobody wants to do that, right? This is super convenient for smaller numbers, but once we start getting into bigger numbers, this is really inconvenient. And it's going to take a long time if your numbers are higher than little bitty 1-digit numbers. So it's good because it's visual. You can see it. Your brain can wrap itself around it in a different way. It's bad because it takes forever, and you can't really use it on bigger numbers unless you've got like a piece of poster board in a day. And you really like counting X's. Really, really. So, are we going to do diagramming this year? Yeah, a lot of it. Because it's a better way for us to understand, or not better, it's a different way for us to understand math rather than just straight up looking at the numbers. Grid or array. This is something you guys have already used. Have you ever opened your planner and seen the multiplication grid where it says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10?
I picked a brain one later on this year, and I'll explain it to you and you guys
Yeah.
pretty much.
Yeah,
So,
no problem.
I was gonna ask you a couple questions.
Yeah. We'll leave that on YouTube. It'll be fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 across the side and across the bottom, right? That chart where you can go and you can say, okay, 5 times 6, and slide your fingers and look up the answer. Multiplication chart is a grid. Watch this. Well, let's keep our same question right here, right? 3 times 4 because it's easy. 1, 2, 3. 1, 2, 3, 4. I'm going to finish out my lines. This is a grid. It goes over 3 and up 4. I could put this on graph paper too, right? If I put this on graph paper, I'd just be counting boxes. How many dots do I have? Sir?
I forgot. 12.
Ma'am? I have 3 groups of 4 dots, so I have a total of 12 dots. If this was squares on graph paper, it would work the exact same way. All this is a different way to diagram. It's a drawing, it's visual. And that can help us in another way too. So, if you're really struggling with memorizing some multiplication tables and the little X thing is not working, can you print off a piece of graph paper or ask me for a piece of graph paper and graph it? Yeah, totally. Pluses of grids and arrays. Different kind of diagram. I'm thinking of a different class for this one. I'm thinking of a different class where you do this a lot. Ma'am? It's easy to draw. And for some reason, she sees this as hard to draw and this as easy to draw. Her brain sees this as more organized, right? What else? Other than it's an easy way to draw, it's easy to keep track, keep organized. Think science class. You do this in science class? All the time when you graph information. This is what a graph is made out of, right? Going this way and going this way. Your x-axis, your y-axis. You keep one set of data here and one set of data here, and you make your mark in the middle. A line graph, a bar graph. All that stuff is built on grids and arrays. You do it in math, you do it in science. You may well do it in reading if you're reading nonfiction, right? Pull out an AR book, it's got a graph in it. You will see grids and array multiplication all the time. It's just usually not called multiplication. It's usually called graphing. Good so far? These are the easy ones. How about standard or old school? In my experience teaching math, people usually, I would say about 40% of people like to use this one best. Probably another 40% of people like to use this one, and there are some weirdos like me who always think about multiplication this way. Now, I'm going to move us up to 2-digit times 2-digit. Our goal in 5th grade is 3-digit times 3-digit, becoming not a problem. And it won't be, once you see the pattern in it. If you saw our patterns yesterday with those moving zeros, it's the same pattern today, just in a different way. Old school, this is how your parents learned it. This is how I learned it. This is how your grandparents learned it. This is how their grandparents learned it. I'm talking old school this is the way most people have ever learned multiplication that I know of in America. So, you've seen this a zillion times. Start with our ones column first, correct? We're going to multiply our 7 times 23. What is 7 times 3? Sir?
21.
I bring down my 1 because that's in my ones column. And I carry my 2. Now I take my 7 times my 10 columns, just 2. What's 7 times 2, sir? 14 plus another 2 is 16. So I know 7 times 23 is 161. Now I need to take this 10 times 23 because this plays like a 1 and it looks like a 1, but remember where it's at. Its location is what gives it its value. It's not a 1, it's a 10. So what do we do with that empty placeholder 0? Throw it away? No, because then it shrinks to a 1, right? What do we do with that empty placeholder 0, ma'am? That's okay, no big deal. Sir?
Put it under the 1.
We just move it down right here automatically. We know when we multiply something because of that identity property, we know we're going to get a 23 because 1 times anything is itself. We're just taking that placeholder 0, sticking it right where we know we need it because that's part of the laws of how multiplication works. Now, 1 times 23. We don't need to make it any more complicated than that. So we did our ones column and our tens column separate. Now to get our total answer, we have to put the whole thing together. So 1 plus 0 is 1. 6 plus 3 is 9. 1 plus 2 is 3. Old school. It's not hard, right? What are some pluses? Sir?
It's not hard.
It's not hard. It's pretty self-explanatory. It's totally based on that base 10 stuff we've been talking about forever. Ma'am. It's pretty quick. You don't really have to do any drawing. You just kind of set it up and knock it out. And if you're a person who is not interested in fancy stuff in math and you want to set it up and knock it out, go for it, do it. Sir.
That's how I learned that.
That's how almost everybody learned multiplication. There are a lot of times kids will take home some of the newer ways we talk about math, and they're not all that different than what I learned as a kid. But I learned it again as a teacher, and I learned how you guys are learning it. Your parents didn't. Your parents have other jobs. They're busy doing their other jobs during the day. They may not recognize lattice or box or cluster, but I guarantee you, your parents, your grandparents, your great-grandparents, your great-great-great-grandparents, they will recognize this. It's how they learned it. It's quick, it's simple, it's to the point. Negatives. See this guy right here? This guy right here causes people problems. Because they think that this is a 1. They treat it like a 1. They forget where it's at, and we forget to drop the 0 down. 99% of people I've ever seen get a problem like this wrong forgot the 0. Or if you're doing 3 digits times 3 digits, you have to put in 2 zeros because that number will be in the 100s place, right? Messing up that 0 is the number one way I've seen 5th graders mess up standard multiplication. So it does have a negative too. You have to do a little bit of remembering, but once you get that pattern, it's not so bad. Lattice. I hated lattice. The first year I was teaching math in 5th grade. One of my former students, who's a custodian now, came in and said, Mr. G, when I was in the service, I was over in Japan. Saw these kids, and they were doing multiplication, and I totally understood it, because this always messes with my head. And I said, okay, show me. And he draws this great big grid paper, and he takes like a 5-digit number times a 5-digit number, and he solves it in like 30 seconds, and I'm just staring at it with my mouth open like he's like swallowing swords or juggling fire, because I'm just like, dude, this is crazy. I don't even know what you're doing. And I was like, there's no way this works. He said, get out your calculator and check me. Pulled out my phone. Perfect. What did you do? So, of course, I got on YouTube like everybody else does, and I started searching lattice multiplication. And there's this little 3rd grade girl doing lattice multiplication. And I'm 30 with a master's degree in education, watching this little 3rd grade girl going, click, watch it again. Click, watch it again. And about my 5th time through, I just all of a sudden went, where has this been all my life? Because the thing that I, as a student and teacher, always mess up, I forget everything. How many times do you forget the 0 if I lose my cup of coffee 10 times every day? About half the time, I'm going to forget the 0. I'm going to do my multiplication, and there's nothing more frustrating than doing all that multiplication correct and then getting the answer wrong because you forgot to do this. Right? I'll tell you straight up, one of the pluses of lattice is you don't have to do any carrying like this. You don't have to bring down zeros. It's pretty straightforward. Lattice uses a grid and then we do these slash marks through it to carry our numbers down. It's like a grid and a slide. And we would say 23 times 17. Parents, if you're watching this, I know this looks like new fancy weird math. It's so easy. It looks strange though. We're gonna match our boxes. We're gonna use this grid where we would say here and here and meet. So we're gonna take this 3 and 1. We're gonna come here to this box and we're gonna multiply together. What's 3 times 1?
3.
3 in my ones column. Nothing here. Placeholder. We don't have anything. We're going to treat every number here like it's 2 digits so that our addition works. What is 1 times 2?
2.
And what we're doing here is we're starting to line up our place values, but we're lining them up sideways by sliding these numbers down with addition, like we did right here. So what is 2 times 7?
14.
Thank you, ma'am. 14. And then 3 times 7.
21.
You can see now when I just asked those 4 different questions about multiplication that are very simple multiplication, why those simple multiplication facts, if you don't know them, will really mess you up. 4 facts to do this one before we even start adding. So now we're going to add down our slope. 1, 1. 3 plus 2 is 5, plus 4 is 9. 2 plus 1 is 3. 391. 391. How many of you guys are familiar with using Lattice? She's never seen it before. Your look on your face is the same as the first time I understood. It's like, what? I spent a lifetime moving zeros down and then went to throw my pencil across the room because I forgot to move zeros down? I do not think Lattice is faster. I think whichever one you get good at is faster. For people who are solid math people, who are really good with numbers, this makes sense, and they hate this. For people who are a little more picture thinkers, this can be their worst nightmare. This kind of brings some of this groups of groups and some of that grid and array stuff that picture thinkers use. This brings that in and combines it with the numbers. And for some reason, a lot of people who think in pictures think Lattice is easier. I will tell you in 5th grade, I could not possibly care less which one you do. Which one is your go-to? Now, there are going to be times where I say, try this, or try this, and I will make you do just the one that I picked. There won't be many times I will have you do that, but I want you to try out all your tools to see which one you're more comfortable with. You may think that you're more comfortable with this one, but actually you're more comfortable with this one, or this one. This is basically like trying on shoes. You can't look at a pair of shoes and know whether or not it's going to fit. You got to put them on your feet and walk around a little bit. So I'm going to make you in 5th grade try on your shoes with multiplication and walk around and see which one you like. But after you try them out, I don't care if you use standard, I don't care if you use Lattice. Most people will pick one of those two because these are very specific ways of thinking that not a lot of people do. However it works for you, you're going to get the same answer, right? Who cares what road you drive down to? If you're driving to a place and you get to that place, you get there. It doesn't matter what road you take, does it? All right. Now let's talk about box. Box looks like Lattice. Any of you guys familiar with box? A lot of people familiar with box. All right. I hope I don't mess it up, both because I'm on YouTube teaching it and you guys already all know it. What we have to do with box is take our numbers apart into place value. 20 and 3. 10 and 7. So 20 plus 3 is 23. What form of notation is this that we studied first day of school? Take those numbers apart into place value. Starts with an E. Ends with expanded. You're warm. Yeah, it's expanded form. We just took our numbers apart into expanded form. Now we're going to multiply all the pieces together while they're easy. And then we're going to toss them back together. We're using addition. Can you give me like 5 minutes? And then I'll come to you. Sure. Okay. Because we're on YouTube. That's all right. 3 times 10. 30. 20 times 10. Okay, so what's 2 times 1?
2.
2. Empty place value? Empty place value. Right? Now we move down. 7 times 2? 14.
14.
Empty place value there. 3 times 10? You think if we add these all together, we're going to get 391?
Yeah, no.
Nope, something went wrong. Because I did 3 times 10. What's 3 times 7?
21.
Told you, when you mess up this kind of math, it's never the hard stuff. It's always the easy stuff. So 200 times 30, or plus 30, plus 140, plus 21. 0 plus 0 plus 0 plus 1 is 1. 0 plus 3 is 3. 7, 9. 2 plus 1 is 3. 391. Personally, I do not like box because I do not like this at the end. Now, does it matter what I like when it comes to the way you think about math?
No.
No. I will tell you, that messes me up. I don't know why, but it's hard for me to think about it that way. I have had other students, they have never been able to do this and never been able to do this. We'll pull this out, and all of a sudden they completely understand it. I had a student a few years ago invent this for himself. He went home and he was tired of being frustrated with his math, so he sat down and tried to figure out, invent his own way to do multiplication. All by himself, and he invented this for himself. It already existed, but he didn't know about it. He came in the next day, Mr. G, look what I did! And I was like, I have no idea what you did, but your answer's right every time, so clearly it works. He said, I just took it apart and put it back together. Took it apart, put it back together. I think box takes a long time. People who are good at box think it takes 4 seconds. What are some pluses of box?
Super easy.
It is super easy. None of your actual multiplication you're doing is hard there. It's just knowing about your empty place values and multiplying.
It's not like you don't get stuck a lot of times.
Yeah, you don't get stuck very often. It's not quite as confusing as, you know what I mean, all those crossovers. And the crossovers like this. It's also easier to draw in Lattice.
I personally.
You think it's quick?
I can do it better.
That's what matters. Doesn't matter what anybody else can do. It matters how your brain thinks about it and how you use it. I'll tell you, you're the first group of 5th grade math students I've ever had that had more than 2 people raise their hand about knowing about box. Never seen it before. That doesn't matter, does it? Cool. Then it looks like I'm going to have to be practicing box so I can grade your stuff. Yes, sir.
My favorite one is.
I could have picked that about you. All right, one more. Let's talk about cluster. Cluster is an unwrapped box where you just write the equation 20 times 3. Oh, 20 times. Let me start over. We're going to go piece by piece because this is confusing to me too. This is my weakest one. I'm going to take the tens place times the tens place. 20 times 10. Then I'm going to take the tens place times the ones place. 10 times 3. Tens place times ones place. 20 times 7. And ones times ones. 7 times 3. Now I'm going to set this up as 4 different equations. What's 10 times, or 20 times 10? Oh, we already have it all. Box and cluster are very, very similar. But cluster just takes the box out of the mix. Yes, ma'am.
Is it kind of like the box is like your problem to do, and like cluster is like your checking?
I could not be more happy that you just said that on YouTube. Yes, the box is your organization so that you don't have to set up all these equations. But if you're an equation person and you like them and you don't like the visual, you can totally just set up all the equations and add them together. You're going to get the same thing no matter what. That's the main idea of multiplication, right? You're always going to get the same thing if you do it correctly. All right. Let me stop videos and we'll finish some more questions.